Reality
Yes.
quiz, so is it gonna have like multiple choice and then a free response like this? Or
I mean, that's usually the setup, right? And I'm not trying to be sassy, but
yeah, I know.
my quizzes are pretty cool. So let's keep going. We're working on part B. Part B is the one that requires 2 brains.
You know what the hypotenuse
It's asking us for the the distance.
When is this changing? When is this
Oh, I mean, this is just X over S. So you can work it with that.
Oh yeah, I just used the A.
Yeah, that's convenient. Here I go.
Those are my notes. Oh, did you understand?
That's maybe this angle, right?
Yeah, so that would be theta.
Theta?
You gotta get theta.
So you go like cos. So cos would be adjacent over so write down, just write cos theta was adjacent over hypotenuse or like x over 10.
Why?
And then you just find the derivative of that. So like I know.
What derivatives mean?
It's between
Oh, seven?
and the radar tower. So 10 is the hypotenuse.
Okay. You didn't pick up on I don't think he wanted to see his homework.
Wait, don't we know this?
Wait, yours isn't in here though.
I don't know, he's giving me So where are we? Right here.
Okay. So cosine of theta is adjacent over hypotenuse, and that's true, but here's the thing. I think what's making life harder for you is that you're using variables that I'm not using. So is it true that cosine is adjacent over hypotenuse? Yes, but what's the adjacent in this problem?
X.
And the hypotenuse?
X.
It is s, yes. So the cosine of theta is x over s.
So it's not 10.
There is a moment when it's 10. Right, it's not constantly 10 miles away. The plane is constantly 6 miles above the ground, but depending on how much time has gone by, the plane's going to be at different places, different distances. So you need an equation that is always true.
Okay.
Right, if you say x over 10, that is true at one moment in time, not always true. It needs to be always true.
Oh, it makes sense.
We just know one of those it's not an 8, so we need to be
Oh, it just needs wait, we don't know.
Oh, ugliness.
Oh, yeah.
Tangent of theta.
Yeah, that's what he's saying.
Okay.
Using sign.
Okay, so hopefully for your setup, you've picked one of those 3, but it has to be something that's always true. And I just realized when I looked at my work, I made a mistake. I blew it. The thing we were just talking about when it said 10, you're not going to use 10 in the initial equation because these need to be things that are always true. So if I'll go, how many of you guys went with the sine version? So much easier because you have a constant in there. And so when I take the derivative, I'm going to say cosine theta d theta dt over here is going to be negative 6 over s squared ds dt. I want d theta dt. Do we know s?
Yes.
S in this problem is going to be
10.
10. Do we know ds dt?
Yes.
That's what we got in part A, right? And so this is going to be one of those things. If tomorrow, if you make a mistake in part A and you use that answer again in part B, I'm going to say, all right, you made a mistake, and I'm going to follow along, and you're not going to lose any points. But you'll find what S is, you'll know what ds dt is. And then to get cosine of theta, you're going to have to say, well, in the moment I'm interested in, the cosine of theta is, what is it, 8 over 10? Because you would do the adjacent over the hypotenuse. So you're going to have something that's going to look like 8 over 10 d theta dt equals negative 6 over 10 squared. And what was ds dt?
Negative 400.
Negative 450, and then you'll just solve it for d theta dt. Ron Beer, what's up?
I thought like if we're gonna be taking the derivative of the 6,
Yep.
shouldn't that just like turn to 0 because it's a constant number?
Okay, so there's two ways you could consider taking the derivative of 6 over s. One of them, I see you, hold on. One of them involves quotient rule, right? Because we've got a fraction. The other one involves saying, well, this is just like 1 over x. And the derivative of 1 over x is negative 1 over x squared. So that's why the derivative is negative 6 over s squared. Lots of options there. Jasmine, what's up?
Why didn't you put n in for s when it gives you that?
Because the statements that we're going to work with in the beginning have to be always true. And the airplane is always 6 miles above the ground. But there's a moment in time where the airplane is 10 miles away from the radar station, but it's only 10 for a moment, and that's the problem. Are you okay with that? All right, so I need somebody. Anthony, would you be willing to drive my laptop? All right, I want you guys to flip over to page 2. I'm excited. I have only ever done this problem once in my life with live students, and that was with the BC students. And that did not go so well. But I think today's going to be even better because I've got stuff, and Anthony's going to help us understand this problem. So, Noemi, when you get a second, can you read this model problem?
A man 6 feet tall walks at a rate of 5 feet per second away from the light that is 15 feet above the ground. When he is 10 feet away from the base of the light, at what rate is the tip of his shadow moving?
Okay. So this is coming. Why is it not coming? I tested this out earlier, and it looks like someone disconnected me.
Can you explain why that's 450 and 500?
Can I explain why it's 450, not 500? Probably not right now in this moment, no.
It was 400.
It
It
was 400.
was given to you in the first problem.
Oh, was it negative 500?
Wait, you were looking for ds, and it gave it to you in the problem.
Okay. Okay. Sorry, got a little distracted. Let's focus on the lamppost question. So, what's happening? What's this guy doing?
Walking away from the
He's walking away. If you have ever walked away from a lamppost, where is your shadow? It is in front of you. Anthony, hit the walk button. And we're just going to watch this guy walk. Yeah, just click it. It's okay.
I hear him clicking.
Anthony, are you clicking?
He's clicking.
You're-
Technical
And,
difficulty.
Anthony.
What did you touch? You touched something you weren't supposed to
hold on,
touch.
Anthony. It's not Anthony. Oh, yeah, it is Anthony's fault. Sorry, Anthony's fault. All right, Anthony, hit walk.
Wait. Ha 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 ha.
Okay, so he's walking away from the lamppost. Shadows in front of him. What are the things that are constant? Let's get some hands on this. What are the things that remain constant all the time? Jennifer? His height. He is not actually getting taller or shorter. Daisy, what else is constant?
The height of the lamppost.
The height of the lamppost is 15. Anybody else see anything that is constant?
The weight, the amount.
We've got right triangles, right? In fact, you've got two right triangles. You've got a big right triangle that involves the lamppost, and you've got a small right triangle. You've got a right triangle inside of a right triangle. Always true. Things that are changing. What are the things that are changing?
The distance from.
What's changing?
The length of like the little small triangle.
Like this guy here?
No.
What-
Oh, yeah.
So that little small triangle, that represents the length of his shadow. So his shadow is getting longer as he walks away. Jennifer, what else? The distance, right? His distance from the lamppost is changing. Anything else changing? What's changing?
Time.
Time. These things are changing over time. This is a related rates question. Anthony, anything else that you see that's changing or staying the same that we haven't talked about yet? The what?
The distance from the lamp to the shadow.
The distance from the lamp to the tip of the shadow is changing as well. Marvin, anything else?
Is the rate in which he's walking staying constant?
I think this is set up so that he is walking at a constant rate. He's not running or slowing down. It's a constant rate. Are we okay? Mm-hmm. All right. So let's freeze this. So let's get him to stop walking, and let me move away. So let's set this up. I have a feeling that once we get the things in place, it's all going to go well. So a man 6 feet tall walks at a rate of 5 feet per second away from a lamppost. That's 15 feet. So I've got a lamppost that's 15 feet. Always or sometimes?
Always.
Always. This is good. Things that are always true are good for us. Another thing that's always true, I heard you guys tell me before, is that he's always 6 feet tall. He doesn't get taller or shorter. And let's see, he walks at a rate of 5 feet per second away from a light. So if I'm going to call this guy over here X, then the rate that he's walking has to be dxdt. Is everybody okay with that? Okay. So dxdt in this case is going to have to be, was that 5 feet per second, positive or negative? Positive. No, why positive?
Because it's going away. So it's positive.
He's going away, which means that the distance that he is from the lamppost is increasing. This is the key. So dxdt is equal to 5 feet per second. And when he is 10 feet away, so that's there is a moment, right? There is an instant when he's 10 feet away from the base of the light. At what rate is the tip of his shadow moving? I want to know how fast the tip of the shadow is moving. So I'm going to have to introduce another variable here. The other variable I'm going to introduce, I'm going to introduce y. So let me get a different color going here. Y is going to be the distance from the lamppost to the tip of his shadow. Okay. So x is how far he is from his shadow, and as we saw, the shadow is always out in front of him. The shadow has some length, so y represents the distance from the lamppost over to here. What I'm looking for is dy dt. Right, that's what I'm looking for, dy dt. Is there a relationship that's always true? Because the key earlier was having your Pythagorean theorem or your trig, that those relationships were always true that connected the variables. Is there a relationship that's going to connect x and y in a way that is always true? Why don't you talk at your tables about this? It's a geometry concept, it's not a calculus concept right now.
No, not the little one, the little one. Not the big one.
Okay, it could be x plus the distance from the man to the shadow. To the shadow, but I don't know what that's called.
Like with 15?
If you need a little bit of a nudge,
Oh.
there's a triangle here. And another triangle here. You've got a triangle nestled inside of another triangle. Way back in geometry, you would have called those similar triangles. Similar triangles are proportional. So similar triangles are proportional. This is going to be one of those times where the constraint is actually hidden from you in the beginning. But what I know, if I've got similar triangles, when I compare side lengths to each other, there's a proportion there. So if I look at the big triangle, I could say something like 15, so the height to y. So this is a comparison of height to, what does the y represent?
From the post to the tip.
It's like distance from post, right? So distance from the post. So the ratio of 15 to y has to be the same as the ratio for the small triangle. The small triangle, now we're talking about the man, his height's going to be 6. And this piece over here
Y minus X.
should be y minus x. Y is that whole length. X is this piece over here. This piece that I need is 6 divided by y minus x. And this is always true? Since it's always true, the good news, you can take a derivative of this. This is what's going to get you into the world of dy dt so you can finish off the problem. How comfortable are you guys with finishing it off from here?
How is it that that gets a zero?
How's it going to get dy dt showing up? Because we're going to use the quotient rule. You're going to take a derivative with respect to time. So quotient rule over here, and do a little bit of solving. This is always true, so I can take a derivative. Here's some good news. There's some legal stuff you can do here that's going to make your derivative life better. Can anybody think of a way to alter this so that it is still always true? 15 over y equals 6 over y minus x. This is always true. I can find the derivative. The other thing that's always true, you guys have been doing this with proportions since 7th grade. Cross multiply. Is it still always true? 6 times y equals 15 times y minus x. Always true, right? If that's always true, then I can take the derivative. And I don't need the quotient rule. I just increase the likelihood I'm going to get this right. Other legal things you can do before you take a derivative, algebra is always good. Algebra is always welcome. So legal algebra, maybe you want to distribute 15y minus 15x. If there's any other legal algebra that you see, feel free to go and do it.
Oh.
Eunice, what do you see that would be legal? I've got 6y over here, I've got 15y over here. I can get those onto the same side. Right, maybe I want to subtract the 6y and say that means 0 equals 9y minus 15x. There's a lot of good algebra that you can do that made your derivative life easier. So if I finish it off, let's take the derivative. 0 equals 9 derivative of y dy dt minus 15 derivative of x dx dt. What I'm after is dy dt. 9's a constant, that's good. 15's a constant, that's good. Do we know dx dt, Christian? What's dx dt? 5. Take 2 minutes, finish this problem off. I want to know what dx dt is, and I want your concluding sentence. if all goes well, dy dt, you're gonna get 75 over 9. Maybe you reduce that to 25 over 3. I want the sentence. What is the sentence? That sentence.
And the guy is 10 feet away from the base of the light. The tip of the shadow is increasing, and the rate of
Nice, 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 nice. All right, I'm feeling pretty good about the sentences. Time to up this one more time. If you guys find on page 3, there's a problem called the conical tank.
Oh, Lord.
So go through, I want you to, first of all, read through this, mark it up. Any information that you think is important, that would be good. Anthony, do you see on the geometry sketch pad, there should be a little tab that says conical tank.
About 25 feet.
Often the college board starts awarding points for your ability to translate what they've given you into a math statement. Let's get some hands. What do you know for sure?
The radius is 40.
The radius is
40 centimeters.
40 centimeters. Now, always or sometimes?
Always.
Always, but here's the thing I want to be really careful about. That radius of 40 centimeters isn't the radius of the water. It's the radius of the cone. So we're saying that this guy up here has a radius of 40 centimeters, and that's always true. Other things that we know for sure. Units, what else do you know? The height is 80 centimeters, always or sometimes? Also, always. The height is 80 centimeters. What else? What else? Only one person sees something else. What else is in there? Adriana, what else do you know?
Was the water is at a height of 30 centimeters, the depth of the water is decreasing at a rate of 1 centimeters per second.
So when the height is 30 centimeters, the depth of the water is decreasing at a rate of 1/2 of a centimeter per second. What is that? The depth of the water, what is that? Volume, if it was volume, you've got the wrong units. David, let's leave the cups, huh? Okay, if I'm talking about volume, the volume would have to be 1/2, like cubic centimeters. This has to be height. Depth means height. So we're saying that dHdt is going to be 1/2 centimeter per second. Positive or negative?
Negative. This is decreasing at a rate.
Right? What's happened? They poked a hole in the bottom of the cone. The height decreases. So DHCT has to be negative. Anything else that they told us? Did they tell us anything else? There's fish in there, poor fish. We've got height, we've got the radius, we've got the 0.5 centimeter per second. Determine the rate of change of the volume with respect to time. What I want is dV/dt. And I've had some students in the past who are like, you know what, I don't know what the final answer is going to be, but I can tell you right now what the units are going to be for dV/dt. How many guys are convinced you know what the units are, even if you don't know the number? Anthony, what do the units have to be? Okay, wait, I heard you say centimeters per second with the cube for the seconds? Don't agree with you. Don't agree with you. I'd really like to. David, what are the units going to have to be? Centimeters squared over seconds. Centimeters squared over seconds cubed. And then, sorry. What are the units over here, David? What are they going to have to be? Centimeters cubed per second. I measure volume in cubic centimeters. I measure time in seconds. There have been times on the scoring rubric that they say you get the right units, there's a point. Okay? So now I know stuff about H, I know stuff about R, I want dV/dt, I need an equation. I need something that pulls it all together. Something I can use, that I can take a derivative of. Volume of a cone. And the volume of a cone. Volume of a cone. Volume of a cone. So sad. There's a third. Yes. Okay, so some of you are telling me 1/3 big B times H. It also says it on the formula sheet. This actually is true. 1/3 big B times the H. 1/3, this is actually true. The base, if we're talking about a cone, the base area. Base area. Base area.
The circumference.
Oh my God, base area.
Oh.
Area of a circle is? Oh my. Okay. So the volume is 1/3 pi r squared h. Now here's the good news. On the AP exam, and if this were to show up on the quiz tomorrow, I would give you that one. I don't want that to be what gets in your way. Have a strategy conversation with somebody near you. What are you going to do now? What are you going to do?
What are we gonna do, Nora?
What you going to do?
Take the derivative.
I think we're supposed to be finding dV/dt.
Oh, you're right.
But you keep the constants, right?
All right, so I'm seeing some good stuff happening on papers out there. You've got to take the derivative. Right, I mean, we're talking about applications of the derivative. You've got a formula that is sometimes true or always true? Always true. These are the things we take the derivatives of. So if I'm going to take the derivative, let's do it. dV/dt equals 1/3 n pi. David, that's a constant, right? That's a constant that I'm multiplying by. If I'm taking the derivative of a constant times stuff that I'm multiplying by, what do we do with the constant? Leave it. So it's 1/3 pi. Now is when I've got to do the heavy lifting. I've got to take the derivative of r squared h. I'm going to write it this way because I just think before Thanksgiving break, well, I don't want to blow it. So I'm just going to say it's 1/3 pi times the derivative of r squared h. And to find the derivative of r squared h, I saw it in a lot of papers. Product rule. product rule. Jose, what's the product rule going to tell me here?
2r times dr dt
2r times dr dt
times h
times the h, because we take the derivative of the first, leave the second alone. Love it. Keep going.
plus dh over dt times r squared.
Okay, you did it in a way that kind of caught me off guard for a little bit. I think everybody else would have said r squared times dh dt. Good news, we don't care. So 1/3 pi, that's dv dt. That's probably worth 2 points. All I want is dv dt. That's all I need. Let's see, do we have everything else? 1/3 and pi, constant, that's good. Do we know r?
Yes. Yeah.
Yes, we do.
40 centimeters.
You guys are all either like having an epiphany at the same time in the same way or trying to fake me out. The radius is not 40.
The thing of the cone.
The radius of the tank is 40 centimeters. I want how the water is changing. So what I don't know what that radius is. And you know what? I think I know what the height is. And because they said when the height is 30. But I've got a cone inside of a cone, which is going back to similar triangles. Just like when the guy was walking. I've got a cone living inside of a cone. So a proportional relationship that I can use here, I can compare the height to the radius of the water to the height and the radius of the cone. So what is that, 80 over 40? The height here compared to the radius, the height here compared to the radius. I can do a little cross multiplying if you want to. So 40 times h equals 80 times r. So I can divide both sides by 40 to get h equals 2r. 1/3 and pi, those are constants. What's the radius that I need?
You wouldn't put 30?
Should you have divided?
Yeah, wouldn't you?
Plug in 30 for H and then.
So you've got some options here. You could have said 30 over r equals 80 over 40. Or you could just say this relationship's always true, h over r equals 80 over 40. Cross multiplying to get that the height's equal to twice the radius. They said h is equal to 30. Well, if h is equal to 30, then 30 equals 2 times r. And so r is going to have to be 15. So over here I've got 2, I've got r. Do I know dr dt? I don't actually know dr dt. Do I know the height? Yeah, they said h is equal to 30. And I know r? dh dt? That's the negative 1/2. I want dv dt. I need to get to dr dt. And there's a reason why I wrote this guy over here in the way that I did. The height is equal to twice the radius. This is a relationship that's going to be true all the time. If this is a relationship that's true all the time, the good news, I can go take the derivative of this. Whenever you've got a relationship that's always true, so go take the derivative, that means that dh dt is going to be equal to 2 times, what is that, dr dt? You know what dh dt is, that's that negative 1/2. Using this relationship over here, you can figure out dr dt. Once you get dr dt, you'll have this last piece that you need so you can get dv dt. Why don't you guys take a couple minutes, finish this problem off. Yeah.
So if you plug in 30 initially, would you not be able to get the answer?
Well, but the problem is you can only take the derivative of things. And there is a moment in time when the height is 30. But it lasts for just a moment.
Yeah. Oh, so
Right, you've got, Rombear, you've got to keep things general for as long as you can so that those are the things you take the derivative of. After you found the derivative, then you can evaluate.
Yeah, and then you will make them two.
Where are we?
Negative
1 over 4 is what? Is gr over dt. And so now it's just a matter of plugging all the junk in. And you know, if you want to simplify, simplify. If you don't want to simplify, don't simplify.
I can leave this big chunk.
Yes. Are those all numbers?
Yes.
As long as they're all numbers, you can leave them. But some good practice would be simplifying, because if it's on the multiple choice, you can also simplify.
that's right.
15, that's
15 squared.
Ours?
155. No, 200 go on that, right? If we say it's just round.
For the win.
I get it, and then I doze off, and then I'll
YouTube and chill.
I think Mars is the same.
Right, water is leaking out the volume.
calculator and that.
It's very this way. That's where they go.
No, but
So
that's
negative 30
Negative.
I don't know what's up there. I think minus the software.
Plus high battery.
no, you're just like,
You don't need a calculator. You're smart guy.
You gotta blend it in.
Are you going to get a positive answer or a negative answer?
Negative. No, positive. Because it's negative 1/4
kind of, but like, just leave it.
Think about what your UV is. What does that mean?
And then the lipstick is just gonna come off of that part. And
It
then
just means volume.
It's how the volume is changing, and I just heard you say that the volume is decreasing. Marvin, where are you going? You're not like packing up early and like getting ready to get out of here. No. Oh, you're not feeling well. I'm sorry. You'll be okay. It's called man up. Okay. So volume is decreasing, so the UV has to be negative. Sure, everybody's being negative.
can I turn it off?
Yeah.
So we do it then.